So welcome everybody to this latest GCSE revision video on 162 Math, and in this video we'll be going over the advanced information given to the Foundation Paper 2 number section, and we'll be going through what topics to revise, what each topic usually contains, and with a brief prediction of what types of questions could come up in your paper. So on your screen what you can see is the number section of the Foundation Paper 2 that AQA have released regarding this paper. Now on this list you can see we've got an order of operations, fractions of a number, improper fraction, fractions decimals, number line decimals, number problems, prime numbers, cube numbers, decimal place, and inequality notation. And what we're going to do in this video is we're going to go through each of the topics written down here and try and get an understanding of what the topics will include, but also try and guess what type of questions you could get. Now obviously what you need to bear in mind is that some of these topics are not going to be exclusive and be standalone. They may be merged into other topics in algebra or geometry and measure, so don't automatically think that this question is going to be obvious to see. It may be used in other topics. So let's have a look at the first one. So order of operation. Now this is basically BIDMAS or BODMAS, depending on how you want to call it. Now the key thing to remember is that this is a calculator paper, don't be afraid to actually use your calculator. The marks will be sort of affected if it's a basic BIDMAS question where you've just got to work out a calculation with a mixture of adding, subtracting, multiplying, dividing, powers and brackets. Then use your calculator, but make sure you know how to use your calculator correctly. So if I load up my calculator, what you want to do is make sure you know which buttons are your power buttons, which ones are your root buttons, and also working with multiple roots. So if you're working with multiple powers, use the button that's got an X and a little box next to it. If you're looking at multiple roots, so what you want to do is press shift and then that, and you can then enter the root and then enter the number that goes inside. Also to bear in mind is know that when you work with negatives and powers, make sure you're putting your negative numbers in brackets, and the reason for that is this explanation that I'm about to do. Now if we wanted to work out -2 squared, well, using your mental arithmetic, -2 times -2 should be +4, because 2 times 2 is 4, a minus times a minus gives me a positive number. But if I enter this on my calculator, as you can see on the screen, my calculator gives me -4, which is obviously incorrect. Now the reason your calculator gives the answer of -4 is because it's programmed with BIDMAS, and the fact that it's done the power first and then taken the negative, so that's why it's come out with -4. So if I wanted to use my calculator to tell me what -2 squared was, I put the -2 in brackets, then square it, press equals, and it now gives me the correct answer. Now again, as this is on a calculator paper, it's unlikely that you'll be given a calculate problem unless it's using powers and roots. And as I've showed you, if it is going to be using powers and roots, they're more likely going to be beyond 2s and 3s, and so squares and cubes, but also your base number is going to be relatively large as well. Now I would say, if I was to put a guess and use my sort of guessing what type of question it could be on a calculator paper, I would say it's more likely to be a countdown type of problem where you're given, let's say, 4 numbers and you need to use those 4 numbers to make another number using the operators of add, subtract, multiply and divide. Or it's a case of placing brackets in the right places. Now there are several websites, several worksheets and past exam questions that cover these types of questions, and they're quite readily easy to find, so you may want to practice. You can even make them up. Ask someone to make up a number, give them a set of numbers, and then you ask them to mess around with their calculator, give you an answer, and then you've got to work out how they got that answer using those numbers. Also, if you do get a countdown or place in brackets question, then this is also going to be classed as a number problem as well. So number problem is such a generic question. It could involve problem solving. It could deal with just basically if a bus can hold 50 people and there's 326 people on going on a school trip, how many buses do you need to order? They're type of number problems you could get. So number problems is so vague, I couldn't really guess what that's going to be. It's just going to be a problem involving numbers, which I know sounds quite self-explanatory. Moving on to fraction of a number. Now again, you can work out fraction of a number using your calculator, so make sure you're doing this. Remember, it is a calculator paper. The word of means times, and you also want to know how to enter mixed numbers on your calculator. So for example, if I just made up a common question, so let's say I wanted to work out 3/5 of, let's say, £42. So for this, all I need to do is get my calculator, and I'm going to use my fraction feature on my Casio calculator. I've got 3/5. Now again, of means times. Now make sure it's on, and again, you always want to check how your display is written on your calculator. Times 42, press equals, and then press the SD button, and it gives me an answer of £25.20. So I can write £25.20. Now again, just be mindful that when you're entering this on your calculator, what you don't want to do is press your fraction button, go 3 and then 5, and then you scroll back to the top, or let's say at the bottom, you then type in times 42. That's going to give you a completely different answer, which gives me 1/70th. And again, I should be able to spot that I've definitely made a mistake. So always check your working out part and make sure it's what it should be, but also look at the answer as well. Moving on to improper fractions. So again, you need to make sure you know how to convert mixed numbers and improper fractions and improper to mixed numbers using your calculator. Now again, on your calculator, you may not realize that this is the case, but if I want to enter a mixed number, then all I'd need to do is press Shift and my fraction button, and I could then enter my fraction part and the base number of that. So if I wanted to enter 5 2/3, I've got 5, 2, and 3. Now what you don't want to do is press your fraction, press 2, press 3, and then scroll across and then type 5, because that then is going to multiply 5 by 2/3. So if you are going to enter a mixed number on your calculator, make sure you are doing that correctly. So let me just do that. And what you can then do is, if you want to convert it from a mixed number into improper, just enter the mixed number, press equals, and it will automatically give you the improper version. So it automatically does it. Now let's say you've given a question where you need to convert an improper fraction into a mixed number. So let me just write a fraction there, and let's stick 7 in there, and I press equals. Oh no, let's give me a nice number. Let's try another one. Let's go for 123/5. Press equals. Now again, because this does not simplify, it's just left it as 123/5. However, if I press Shift and the SD button, it will then convert it into a mixed number for me. So again, as this topic is on a calculator paper, make sure you know how to use a calculator. And again, for calculations, if I wanted to enter a calculation, so let's just make up a calculation. Let's go for 3 1/5 divided by 21 2/3, and that's going to give me a crazy answer, but let's just enter that in. So if I press Shift and the fraction button, I can then allow me to enter the mixed number. So 1 and 5, scroll across, divided by, press Shift and the fraction button, 21, 2 and 3, and press equals, and again it's given my answer as 48/325. So again, easy peasy on the calculator. Moving on to fractions to decimals. Now again, this is on the calculator. You can use your calculator to convert. Now the key thing to remember is when you've got fractions, that line basically means divide. So when you've got 24/5, that is exactly the same as 24 divided by 5. So again, if I get my calculator, and let's say I want to do 24 over 5, let's put that in as a fraction. Press equals, it gives me as a fraction, but if I press the SD button, it will then automatically convert it into a decimal for me. Let's say a question was going in the opposite direction, so let's go for 6.25, and I wanted to write that as a fraction. Well, all I do is enter the decimal, press equals, and it automatically converts it for me. And then again, if I want to write that as a mixed number, press Shift and SD, and it does that for me as well. So now let's have a look at decimal number lines. Now to complete a decimal number line, again, working with scales, etc., what you want to do is just work out what the increments between getting from one point of the scale to the next. And again, this doesn't require any methodology or working out. Sometimes it's just a question you just know how to do. But let's just have a look at how you'd approach this question if the numbers were a little bit more difficult or less obvious for you to do it just by using your mental arithmetic. So if, let's say, as an easy example, let's just go for 3 dashes in the middle, and let's pick a random number for A. Let's go for 3.1, and for B let's go for 3.8. So from this, let's have a look at, and we're trying to find out what decimal numbers would be at these 3 dashes. Now this is one method that you could use to work it out, but again, usually it's a case of when students get this question wrong, they're basically dividing those 2 numbers by the wrong number. Now, so what you want to do here is first of all count the number of dashes, which, so here we've got 1, 2 and 3, so that answer there for step 1 is 3. We add 1 to make it 4, and then for this, what we need to do, if we look at the difference between the 2 ends of the number line, so we've got 3.8 minus 3.1, which is 0.7, and then to work out the increases, what I need to do is do 0.7 divided by 4, and if I do that on my calculator, I get an answer of 0.175. So to work out this number here, I'm going to do 3.1 plus 0.175, which then gives me 3.275. If I then add that again, add another 0.175, then add another 0.175, and again here I'm just adding. That then should tell me what the other numbers are. So 3.275 plus 0.175, it gives me an answer of 3.45. And then if I add 0.175 to 3.75, 45 rather, I get 3.625, and there I've worked it out. Now, where this question kind of divert is, let's say I've got the number that I've been given is in the middle of the number line. So let's go for 1, 2, 3, 4. So let's just make up another number. Let's go for 4.2. And let's say this number here is 4.3. Let's go for 4.4. Right, so for this, what we want to do is we want to fill in these numbers here in between the 2 numbers that I've been given first. So again, following the steps, I've got 3 plus 1, which is 4. So then the difference is 0.2. And so I'm going to do 0.2 divided by 4, which gives me 0.05. Now, from there, all I then want to do is then work out what each of these numbers are. So this is going to be 4.25, then it's going to be 4.3, and then 4.35. And so if I'm here, I'm adding 0.05. Then to work out these numbers, I've got to take it away. So then that then's going to become 4.15, and that will then become 4.1. So make sure you can work in both directions when working with a number line. Moving on to prime numbers. So again, what you need to make sure you're doing is learn the definition of a prime number. Now, the definition of a prime number is not a number that can be divided by 1 and itself. What you want to try and, a better definition would be a number that has only got 2 different factors, one being itself and number 1. Because if you use the definition that a prime number is a number that can only be divided by 1 in itself, then 1 technically is a prime number, which it isn't. So try and make sure you're using the correct definition of a prime number. The next one is that 2 is the smallest prime number and also the only one that is even. All the other prime numbers are odd. And also, I would recommend that you learn all your prime numbers up to at least 50 on the foundation. Ideally, if you can recognize them up to 100, brilliant. But again, I would say just make sure you're familiar with what the common prime numbers are, just in case you get a question where you've got a list of numbers. And this could easily be one of the multiple choice questions at the start of your paper, where you just got to circle which number is prime or which of these numbers is not prime in some cases. Now, if you've got a Casio calculator that's got a fact button, let me just load to see if this one has, and it has there. So as you can see on the button that's next to the negative button, it's just got that written in yellow above the button. It says fact. Now if you want to check to see if a number is prime, you can use this feature to tell you just that. So for example, if I entered 45 and I want to check if 45 is a prime. Now you should know 45 isn't going to be a prime because it can be divided by 15, 9 and 5. And also 3. So if I then check, now if I press shift and that button there, now if it gives me an answer that looks like this, which is a product of its prime, then it's not prime. However, if I entered a prime number like 23 and I press shift and that fat button, if it doesn't change, then, and obviously that doesn't count, so if I press shift and fact and it doesn't change, then that means that number is prime. So if I wanted to check to see if 17,051 is a prime number, I press shift and fact, and so there, although it may look like a prime number, it actually isn't, because it's 17 times 103. Whereas if I typed in 601 and see if that was prime, shift and fact, and as you can see that doesn't change, so therefore 601 is a prime number. So let's move on to cube numbers. So again, what you need to do when you're revising cube numbers is make sure you know how to enter cube numbers and cube root numbers on your calculator. So looking at this, what you tend to find is you're looking for, now again, what I would probably recommend that you do is just use the universal power button to enter cube. So if I wanted to work out what 12 cube is, you can use shift and x squared, but I would just go for this one here. So if I entered 12 and then press shift, oh, what am I doing? So I'm entering this here, 12 and then cubed, press equals, and that's what 12 cubed would be. If you want to check to see if a number is a cube number, then what you then want to do is enter shift and then the cube root feature, and then just type in the number. So if I want to check to see if 124 is a cube number, press equals. If it gives you a decimal number, it's not a cube number. If it gives you a whole number, it is a cube number. So for example, if I want to check to see if 64 was a cube number, press shift and the square root, so the cube root comes up, enter 64, which is the number I want to check, press equals, gives me a whole number, so therefore it's going to be a cube number. Now again, in terms of the cube numbers you're expected to know, you should really know what 1 cubed is, 2 cubed is, 3 cubed, 4 cubed, 5 cubed is, and also what 10 cubed is. Ideally, if you know what 6 cubed is, so for example, and again, but with you having a calculator, there's going to be no expectation for you to do this as long as you know how to enter it on your calculator. Moving on to decimal places. Now, with decimal places, I'm not going to go through the notions. I will attach a video link if you're not sure how to round to decimal places, but it is really, really important that you do. Now, again, whether this comes up as a unique topic or is involved in other areas, so for example, geometry and measure, where you've got an answer and you then need to round that number to a certain degree of accuracy or to decimal places, then that would be a mark in itself. So this could be a question related to itself, or it could be merged with another question. But in terms of this, what you need to know is also place value. So understand your place value. So what I mean by that is if I wrote down, let's say 2.12345, that this number here represents a tenth. So it's going to be 1 over 10. This represents a hundredth. So that's going to be 2 over 100 as a fraction. This would be a thousandth. So that's going to be 3 over 1000 as a fraction. This would be a 10,000th. So that would be 4 over 1 with 4 zeros. And that would be 100,000th. And just ignore the spelling, and that would be 5 over 123, 123. There we go, as a fraction. So make sure you understand your place value. The next thing is to know how to round to decimal places, which is really, really important. The next one is more of a fact. So again, the more decimal places you've got, the more accurate your answer will be. So if a question says, how could you make your answer more accurate? Include more decimal places in your answer. But also, why would you round a number up if it makes it less accurate? Well, having a number rounded, it makes it a lot easier to work with and also a lot easier to say. And also, key thing to note is that whenever you're dealing with money questions, even though this is not involved in money's not mentioned in any other area of paper 2, you always want to round money questions to 2 decimal places. So just like we did previously, if I had an answer of 23.2, then that would be £23.20. So just add a 0 on there as well. Now also, when you work with decimal places, when you're doing adding, subtracting and ordering, just make sure that you've got the same number of decimal numbers in each of the numbers, and if you haven't, then just add 0 so that is the case. So then moving on to our last topic on the number section is inequality notation. So for this, obviously you need to understand and know what the meaning of all the inequality signs are. Now one way of doing that, and the most common way of doing that, is remembering that the crocodile eats the bigger number, or the one that I tend to use, which is the arrow points at the smaller number, because obviously that then implies in terms of looking at algebraic terms. Another symbol that tends to get forgotten is this one, which is basically not equal to. Now, in terms of predicting what type of question you could get, is basically questions where you are given 2 numbers. So let's have a look at some decimal numbers, like so, and you've got an empty box and you just need to enter the correct inequality symbol that goes in. So for example here, that the 3.015 is smaller, so the inequality points in that direction. Where you may get up a greater or equal to one is basically when we've got 25 and let's say we've got let's go for minus square root of 25 and we've got a minus 5, so that therefore could be equal, it's going to be equal to, and in this just a case of filling those in. Now the next thing for you to bear in mind is to know how to represent an inequality on a number line. So again, this could be linked with decimal number lines. So if I had something that looked like, let's say 4.15x, and let's go for 4.25, and let's put a line underneath that one. So again, it's just recognizing what they are. Now with regards to the number line, remember that if it's less or greater than, then it's going to be an empty circle, and if it's less or equal to or greater or equal to, then it's going to be a shaded circle. So going back to this question, if I had a scale, and let's say this is 4.15 and 4.25 with some dashes in between, I'm going to put 2 circles at each end of those 2 numbers. Now for this one, because this symbol is not shade, it hasn't got a line underneath it, I keep it empty, but this one has, so therefore I'm going to colour that one in, and then I'm just going to join those 2 dots with a straight line, and there we go.